Have you ever stopped to think about where the 500 hours of video uploaded to YouTube every single minute actually go? I mean, that is a colossal amount of data. And the solution to handling it is one of the most important fundamental concepts in modern technology. So let's break it down.
Right, think about it. Every photo you scroll past, every video you watch, every document you share, it all adds up to an almost unimaginable amount of data. So where do we put it all? Now, the most obvious answer is actually the wrong one.
Your first instinct might be, hey, just stick it in a database. But that's kind of like trying to store your car in a filing cabinet. It just doesn't fit. It's super slow to get in and out, ridiculously expensive, and it's just not what a filing cabinet is for. What you really need is a massive, purpose-built digital warehouse. And that digital warehouse, well, it has a name: Blob storage. And this isn't just a slightly different type of storage, it's a completely different philosophy, designed from the ground up specifically for the kind of messy, unstructured data that powers the entire modern internet.
So what exactly is it? Okay, don't let the name scare you. A blob is just a nerdy tech term for a binary large object. But really, just think of it as any file: a JPEG image, an MP4 video, a PDF, you name it. So blob storage is simply a cloud service built from the ground up to hold a virtually infinite number of these files.
The core idea here is just brilliantly simple. You hand your file over to the Blob storage service, and in return, it gives you back a unique web address, a URL. That's it. That URL is now the digital key to your file, and you can access it from anywhere in the world. It's a really simple transaction that unlocks incredible scale.
But, there's always a catch. If your main server had to handle every single byte of every upload and every download, it would get overwhelmed and become a massive bottleneck really fast. The solution is this super clever trick called Presigned URLs. Let's walk through how they work.
Okay, so the upload is this clever four-step dance. First, your app, say on your phone, tells your server, hey, I've got a photo I want to upload. Then, your server talks to the Blob storage and gets a special secure one-time use link. Your app then uses that link to upload the file directly to the storage, completely bypassing your server. And once it's done, the storage service just pings your server and says, all good, the file is here.
Downloading is even simpler. Your app asks the server, hey, I need that photo. The server gives it another one of those temporary, secure links, and then your app downloads the file directly from the storage service, often from a super fast local copy on something called a CDN. All the while, your server is totally free to handle other important requests. It barely has to lift a finger.
Now, this whole process isn't just a neat trick. It's the industry standard for some very, very good reasons. It gives us 4 huge wins that, frankly, make building large-scale applications even possible in the first place. First up, durability. Services like Amazon S3 are designed for 11 nines of durability. What on earth does that mean? Well, it means if you stored, say, 10 million files, you can expect to lose just one of them every 10,000 years. They do this with crazy stuff like automatically replicating your data and using erasure coding. The bottom line is your data is almost impossibly safe from just disappearing.
Second, scale. With blob storage, you never have to think about running out of space, ever. It is, for all practical purposes, infinitely scalable. You just keep throwing data at it, and it just keeps working. It's a massive headache for engineers that just, poof, goes away.
And then we get to the cost. And honestly, this is the real jaw-dropper. Storing a gigabyte of data in a high-performance database could cost you over $1 a month. In blob storage, it's about 2 cents. That's not just a little cheaper. It is a completely different universe of cost. It's a total game changer.
And the benefits just keep coming. You get top-notch security with encryption for your data, whether it's just sitting there or flying across the network. You get incredibly fine-grained control over who can access what. And for those really huge files, there's a feature called chunking, which breaks the file into smaller pieces so uploads are more reliable and can be resumed if they fail.
Okay, so we know what it is, how it works, and why it's so awesome. Now let's pull back the curtain and see where you've already been using it, probably every single day without even realizing it, because the biggest apps in the world are all built on this exact foundation.
YouTube, Instagram, Dropbox, you name it, they all use the exact same playbook. It's a classic architectural pattern called separation of concerns. The big, bulky files go into blob storage, and the small, searchable information about those files, what we call metadata, that goes in a database. That's the stuff that lets you actually find everything. This chart makes it crystal clear. Look at YouTube. The video's title, the number of likes, the comments, that's all small text data, perfect for a database.
But the actual video file, the massive MP4, that lives in blob storage. Same for Instagram. The caption, the user, the hashtags are in the database. The image itself is in blob storage. It's this same elegant pattern, just repeated everywhere.
So if you remember only one single thing from this entire explainer, please let it be this. This is the golden rule that architects at every single major tech company live by when they're dealing with file storage.
And here it is, the golden rule. Store blobs in blob storage and store metadata in a database. It's that simple. It's the mantra that makes the entire modern internet possible. If you understand this, you understand one of the biggest secrets of building systems that can scale to millions of users.
Once you really get this pattern, you start seeing it everywhere. Thinking about building a new social media app, an enterprise document management system, a platform for sharing scientific data. The core architecture is fundamentally the same. So the question I'll leave you with is this. Now that you know the blueprint, what are you going to build?